The heavier the mass, it don't move as much. So which is the reason why they will form a white precipitate at the center of NH4Cl here. Now, what is NH4Cl? It is basically a neutralization reaction whereby NH3, which is a base, react with HCl, combine together to give you ammonium chloride. This reaction we will talk about in more details when we reach to acid, base, and salt. But just for now, we just take it as it is. Next, of course, another factor that can affect the rate of diffusion is the higher the temperature. Right? Higher the temperature, that means that the particles will diffuse faster. Think particles like human being. If I were to switch off the aircon in this room, well, I think a lot of people will feel a bit agitated because it's getting a bit warm. It will move a bit faster. The same also applies to particles. Particles, the higher temperature, the faster it moves. Third factor, which is not normally covered, gravity plays a role. So gravity will actually aid or slow down the rate of diffusion. Now, what do we mean by aid first? Take, for example, if I have a container here, now I'm going to put, maybe a gas here. Maybe the gas is bromine gas. Now, we know that the bromine gas is brown in color. Maybe the brown is here. Then followed by this is travel in the direction of the gravity. Can you see that? It travel in the direction of gravity. So this is going to take much faster time. So maybe, you will take about, let's say, maybe 10 seconds for it to completely diffuse throughout because you travel in the direction of gravity. As you know, gravity is going downwards. But let's compare upwards. Take a look on top. Now the bromine is at the bottom. For it to travel all the way up, I think that it's going to take a longer time because this is against the direction of gravity. Can you see that? This is against the direction of gravity. So maybe for them to travel throughout this whole gas jar, instead of from the original 10 seconds, maybe it'll take about 1 minute. Okay, so this is what I mean by against the direction of gravity. And this is what I mean by with the aid of the gravity. So that depends on which direction you're looking at. Okay, that is very important. Now remember I mentioned before that there is a confusion here. The confusion is this pointer. Okay, let me explain to you why this is a confusion. You might not see this as a confusion right now, but this confusion will come in when you do the exam. Because normally when you do the exam, you're a little bit more cautious. You have a tendency to overthink things. Now, why this is a confusion? The smaller the mass, the faster the rate of diffusion. Let's take a look at this diagram here. Now, bromine has a formula of Br2. Br2 has a molecular weight of 160. Now, 160 is very, very high. Now, what about here? Here, this is what we call the gas jar. So, which means inside you have air. Now, what does air consist of? Your O2, your N2, so on and so forth. But you see, what we are interested in is not just O2 or N2. What we are interested in is the molecular weight, because these are the major gases. So what is so-called the average molecular weight of air? The average molecular weight of air is approximate. Like I said, it's approximate. Your MR of oxygen is 32. Your N2 is about 28. So it's an average of these two. Now, we are aware that the percentage of O2 and N2 are different, but if you take the average of them, approximately, it's about 30. It is about 30 here. So by the law of diffusion, we say that the heavier the mass, the slower it travels. So shouldn't the air occupy most of the space instead of the reddish brown gas? Because reddish brown gas is much more heavier. So that's why I say that this is a problem that you might not see right now, but when you're doing an exam, you might overthink. You might overthink that, hey, wow, 160, very heavy. So very heavy, do you think that it can diffuse all the way to the top? That is the problem you may face. So this is the way I want you to think. This diffusion is leave for a long period of time. Maybe you want to write down is leave it for a long period of time. Just like water, water is very hard to evaporate, right? But if you were to leave it there for a long period of time, it can be easily evaporated off. That is the thing that I want you to remember of. So remember, no matter how heavy the molecular weight is, it can be 160, it can be 300, it can be 400, it can even 1000 molecular weight. It doesn't matter. As long as it is volatile first, volatile is the key, it must be a gas. Second, leave it for a long period of time, it can be easily diffused throughout the whole gas chart. Okay, very, very important is the word.